Have you ever gazed at the night sky and pondered the mysteries it holds? The universe, a vast expanse of cosmic bodies and infinite possibilities, is not just a static entity. It's an ever-evolving, ever-expanding canvas of time and space, a profound mystery that has captivated the human mind for millennia. Imagine, if you will, the universe as a cosmic symphony, forever unfolding in a grand crescendo of creation. Each star, each galaxy, each celestial body is a note, contributing to the melody of existence. Yet this symphony is not just playing, it's growing, expanding, stretching the very fabric of reality itself. This is the concept of the expanding universe, a theory that has revolutionized our understanding of the cosmos. It suggests that the universe is not a fixed, unchanging entity, but rather an evolving, dynamic system, continually stretching and growing in size. Evidence of this expansion is etched into the very light that travels across the cosmos. When we observe distant galaxies, we find that their light is shifted towards the red end of the spectrum, a phenomenon known as redshift. This redshift is a cosmic Doppler effect, indicating that these galaxies are moving away from us, suggesting that the universe itself is expanding. But what does this mean for our place in the cosmos? The expanding universe implies that we are part of a reality that is constantly changing, constantly evolving. It suggests that the cosmos is not just a stage upon which we stand, but a dynamic, evolving entity of which we are an integral part. This profound mystery of the expanding universe challenges us to rethink our understanding of reality. It invites us to explore, to question, to wonder. It beckons us on a journey to the edge of all we know. Our journey begins at the very start, the moment that sparked existence itself, the Big Bang. Imagine a moment, an event so powerful, it gave birth to everything we know. It's a concept that's as mind-boggling as it is fascinating, isn't it? This moment, this event, is what we commonly refer to as the Big Bang. The Big Bang theory, as many of you may know, postulates that the universe began as an extremely hot and dense point roughly 13.8 billion years ago. Yes, you heard it right. The entire universe was once compressed into a singularity, an entity so small it's beyond human comprehension. Now, when we say it was hot and dense, we're not talking about a balmy summer day. We're talking about temperatures that are unimaginable, reaching up to 1 trillion degrees. That's hotter than the core of the most massive star, hotter than anything we can currently recreate in a laboratory. In this blistering cauldron, the fundamental forces of nature that we know, gravity, electromagnetism, and the nuclear forces, were unified, indistinguishable from one another. The universe was not yet a place where matter as we understand it could exist, but then, in a fraction of a second, this singularity began to expand. And when we say expand, we mean explosively so. It wasn't an explosion in the traditional sense, but an expansion of space itself. It's as if you're blowing up a balloon, but instead of the air filling it, it's the rubber of the balloon that's creating more space. As the universe expanded, it began to cool, and the fundamental forces separated. The universe continued to cool and expand, allowing the first subatomic particles to form, then the first atoms, primarily hydrogen and helium. These atoms would eventually clump together to form stars and galaxies, but that's a story for another time. This cooling and expanding universe set the stage for all the cosmic phenomena we see today. It's a stage that has been expanding for billions of years and continues to do so. As the universe cooled, it set the stage for the creation of galaxies, a tale of creation wrought from a moment of unimaginable energy and heat. That's the story of our universe. That's the story of the Big Bang. From the ashes of the Big Bang, galaxies started to form. And what a spectacle that must have been. Picture this: colossal clouds of cosmic dust and gas, vast and shapeless, slowly beginning to spin and collapse under the pull of gravity. These spinning clouds, or protogalaxies as scientists call them, are the celestial wombs where galaxies are born. In the heart of these protogalaxies, the dust and gas grow denser and hotter, ultimately igniting the birth of stars, billions upon billions of them. As these stars ignite, they blow out the remaining gas and dust, leaving behind a swirling cluster of stars, a galaxy. But not all galaxies are created equal. Some are spiral galaxies, like our very own Milky Way, with majestic arms of stars and gas spiraling out from a central bulge. Others are elliptical galaxies, round or oval in shape, filled with a sea of stars moving randomly. And then there are the irregular galaxies, with no particular shape, often chaotic as a result of collisions or close encounters with other galaxies. Each galaxy is a cosmic city, home to billions, even trillions of stars. They are the building blocks of the universe, the frameworks upon which the cosmos is built. Can you imagine the number of galaxies out there? Astronomers estimate there could be as many as 2 trillion galaxies in the observable universe. That's a whole lot of cosmic cities. But it's not just about the stars. Galaxies also contain interstellar medium, a mixture of dust and gas that fills the space between the stars. It's within this interstellar medium that new stars are born, continuing the cycle of stellar birth and death that has been going on for nearly 14 billion years. And that's where we come in. You see, every atom in our bodies, the iron in our blood, the calcium in our bones, was once part of a star that exploded in a supernova. We are quite literally made of stardust. Within these galaxies, stars were born, and so were we. The universe's grand design doesn't stop at galaxies. Within these galaxies, stars and solar systems take shape. The birth of a star is a spectacle of cosmic proportions, a process that takes millions, sometimes billions of years. It begins in vast cold clouds of gas and dust, known as nebulae. These nebulae, under the influence of gravity, begin to collapse and condense into a dense core. As the core of the future star grows denser and hotter, a process called nuclear fusion ignites. This is the heart of a star, a cauldron of unimaginable heat and pressure where hydrogen atoms are fused together to form helium, releasing energy in the process. It's this energy that makes stars shine, a beacon in the darkness of space. But stars are more than just cosmic lighthouses. They are the universe's factories, creating elements that will one day become the building blocks for planets and even life itself. Over its lifetime, a star will produce elements like carbon, nitrogen, and oxygen, and as it reaches the end of its life, it will create even heavier elements like iron. The death of a star is as spectacular as its birth. In a supernova explosion, a star flings its enriched contents out into space. These materials then become part of another nebula, ready to begin the cycle again, birthing new stars and, around some, new solar systems. Planets, like our Earth, form from the debris left over after a star is born. They are the product of countless collisions, as dust and rock clump together over millions of years. Some of these planets find themselves in the habitable zone, the sweet spot where conditions might just be right to support life. And in one such galaxy, in one such solar system, our planet Earth was formed. It's a testament to the incredible processes at play in the universe, from the birth of stars to the creation of planets. We are, in a very real sense, made of star stuff, the product of cosmic forces spanning billions of years. In the vast cosmos, our home, Earth, is but a tiny speck. Yet it's a speck that has undergone a profound transformation over billions of years. The story of Earth begins around 4.5 billion years ago, in the swirling dust and gas left over from the birth of our Sun. In this cosmic nursery, countless particles began to collide and stick together, gradually forming a rocky planet. But Earth's early days were far from peaceful. It was a hot, molten world, constantly bombarded by asteroids. One such colossal impact is believed to have formed our moon. Over time, the surface cooled down, and volcanoes spewed gases into the atmosphere, laying the foundation for a life-sustaining environment. Water, the elixir of life, made its appearance. It's believed that comets, icy messengers from the outer reaches of the solar system, delivered much of Earth's water. As the planet cooled further, these waters formed oceans, covering most of the Earth's surface. Now, with water and a stable climate, the stage was set for the greatest show on Earth, the dawn of life. Simple, single-celled organisms appeared around 3.5 billion years ago. Over eons, life evolved, diversifying into a myriad of forms, from the smallest microbes to the largest dinosaurs. Around 200,000 years ago, a new species made its appearance, Homo sapiens. We learned to harness fire, invent tools, build civilizations, and eventually to look up and ponder about the stars. We've come a long way since our humble beginnings in the African savannas, and now we stand at the threshold of becoming an interplanetary species. From the birth of the universe to the rise of human civilization, we have traveled a long way. But the journey doesn't stop here. As we gaze into the vast expanse of the universe, we're reminded of our cosmic origins and the incredible journey of our planet, from a molten rock to a cradle of life. And as we continue our journey, who knows what extraordinary chapters await in the story of Earth and its inhabitants? As we stand on our tiny planet, we gaze out into a universe that continues to grow. Indeed, one of the most profound revelations in cosmology is the realization that our universe is not static, but constantly expanding. But what does this actually mean? Well, it's not that the galaxies are moving through space, but rather, space itself is growing, carrying galaxies along with it. A key piece of evidence supporting this theory is the redshift of distant galaxies. Like the sound of a siren changing pitch as it moves past, light waves from a moving object shift in color. When astronomers observe distant galaxies, they find the light is more red than expected, a phenomenon known as redshift. This suggests these galaxies are moving away from us, and the more distant the galaxy, the greater the redshift. This observation is consistent with an expanding universe where every point moves away from every other point. The second crucial piece of evidence is the cosmic microwave background radiation. This is the afterglow of the Big Bang, the cataclysmic event that kick-started the universe's expansion roughly 13.8 billion years ago. This radiation is remarkably uniform across the sky, but it also shows tiny temperature fluctuations, or ripples. These ripples are thought to be the seeds of all existing structure in the universe. The galaxies, clusters of galaxies, and vast cosmic voids. The concept of an expanding universe has profound implications for our understanding of the cosmos. It suggests that the universe was once concentrated in a single point of infinite density, known as a singularity, which then expanded and cooled to form the universe we see today. As the universe expands, it continues to evolve, holding countless mysteries yet to be unraveled. As we continue to gaze out into the cosmos, we are not just looking out into space, but back in time, exploring our cosmic origins and our place in this vast, expanding universe. As we gaze into the cosmos, we are not just seeing the universe as it is, but as it was. The light from distant stars takes time to reach us, so we're actually observing the past. But what about the future? What will become of our ever-expanding universe? 3 possible scenarios are frequently discussed in the realm of cosmology: the Big Freeze, the Big Rip, and the Big Crunch. Each scenario is based on the universe's current rate of expansion and the amount of dark energy present. Let's start with the Big Freeze. If the universe continues to expand at its current rate, it will eventually become too spread out to form new stars. Over trillions of years, existing stars will burn out, leaving only black holes and dying stars. Eventually, even these will fade, leaving a dark, cold, and lifeless universe. Next is the Big Rip. This theory suggests that the universe's expansion isn't just continuing, but accelerating due to dark energy. If this is the case, then in about 22 billion years, galaxies, stars, planets, and even atoms could be torn apart, resulting in a universe filled with isolated particles. The third scenario is the Big Crunch. If the amount of matter in the universe is enough to overcome the expansion, then gravity could cause the universe to collapse in on itself. This would lead to a reverse Big Bang, or a Big Crunch, where everything in the universe converges into a single point. It's important to note that these are just theories, based on our current understanding of the universe. As we continue to explore and learn more about the cosmos, our predictions may change. While the future of the universe is uncertain, our quest to understand it continues. Regardless of the universe's ultimate fate, we can take comfort in the knowledge that we are part of something much larger than ourselves, and that our curiosity and desire to understand will always drive us forward. In this vast, expanding universe, what is our role? It's a question that has provoked contemplation for eons, a riddle woven into the fabric of our being. We are explorers, stepping over the threshold of our celestial home, Earth, and venturing into the cosmic ocean. From the first human footprint on the Moon, to the robotic exploration of Mars, to the farthest reaches of our solar system explored by Voyager, we've made incredible strides in our cosmic journey. Each step, each discovery, is an affirmation of our innate curiosity and our determination to unravel the mysteries of the cosmos. We are also observers, peering into the depths of the universe with our telescopes, gleaning light from stars billions of miles away. With every observation, we expand our cosmic perspective, tracing the grand story of the universe, from the fiery birth of stars to the silent death of galaxies. We are the universe's way of understanding itself. Through our scientific endeavors, we've uncovered fundamental truths about the cosmos. We've discovered that the universe is expanding, that it began with a big bang, and that it's filled with galaxies beyond count. We've developed theories about black holes, dark matter, and dark energy, concepts that challenge our understanding of reality. We are inventors and innovators, harnessing technology to push the boundaries of our cosmic exploration. From the rockets that thrust astronauts into space, to the telescopes that allow us to observe distant galaxies, to the algorithms that help us decode the universe's secrets, we're continually pushing the envelope of what's possible. But perhaps most importantly, we are part of the cosmic tapestry. We are made of star stuff, as astronomer Carl Sagan once eloquently put it. The elements that make up our bodies were forged in the hearts of stars, scattered across the cosmos in spectacular supernova explosions. In a very real sense, we are children of the universe. As we continue to explore the cosmos, we not only discover more about the universe, but also about ourselves. The universe is vast, mysterious, and ever-expanding. As we've journeyed together through the cosmos in this video, we've traced the universe's grand narrative from its fiery, explosive birth in the Big Bang to the present moment. Along the way, we've seen how galaxies, those sprawling cosmic cities of stars, dust, and gas, took shape. We've marveled at the birth of stars, those fiery celestial furnaces, and the formation of solar systems, including our very own, a testament to the universe's creative potential. We've touched down on our home planet, Earth, a blue-green jewel in the vast expanse of space. Through it all, we've been guided by the profound understanding that our universe is not static, but dynamic, forever expanding into the great unknown. This expansion is not just an idle curiosity, but a fundamental aspect of our cosmos. It tells us that our universe has a history, a story of change and growth. It reminds us that the cosmos is not merely a backdrop to our lives, but a living, breathing entity, full of motion and energy. We've also glimpsed into the future, a future where the galaxies continue their outward march, where stars continue to be born and die, where the universe continues to evolve and change. It's a future full of wonder and potential, but also of profound mystery. What lies beyond the edge of our observable universe? What will become of our cosmos in the deep future? These questions and many more are yet to be answered. But that's the beauty of our cosmic journey. The universe is not a book to be read from cover to cover, but a story that's being written, even as we explore and discover. As we continue our cosmic journey, let's remember that the universe is not just out there beyond the night sky. It's also here within us. We are made of star stuff after all. We are a way for the universe to know itself. As we continue our cosmic journey, the universe awaits, full of mysteries yet to be discovered.